Hello, everyone, and I hope that you're doing great. Now, today we're looking at this past paper for BGCSE Chemistry. It is a paper 2 from 2023. Please remember, as always, write your school number, your candidate number, your surname, and initials. Also, please read through the instructions carefully and ensure that you understand each instruction before you start the examination. If you have any questions before you begin the examination, please refer to your examiner. Now, as usual, they will normally provide you with a periodic table, so that's one less thing to worry about. All right, so let's jump into question number 1, and it reads that a food chemist extracts substance X that is responsible for the characteristic smell of an orange. It can be done in the laboratory using the process shown in the diagram, and I labeled this piece of apparatus A as a condenser. And so they asked us to name the separation technique, and that is simple distillation. And please know the difference between fractional and simple distillation. For part 2 of A, it says state the name of the apparatus labeled A, and again, that is the condenser that is shown in the diagram. And for part 3, it says describe how apparatus A works, and this is simply can just mention it that cold water goes in the outer tube and remove heat from the gas passing in the inner core or the inner tube of the condenser. The water exiting the outer tube will take heat with it. All right, and so that's how heat is removed from the gas passing through. And so it's a simple thing that heat is removed from the gas passing through the condenser, changing its state into a liquid. So moving from gas into liquid. So that's the basic idea. Heat is removed from gas, change it into a liquid form. All right, so for part B, it said in an orange flavored candy, the orange dye provides an authentic orange color. It said the food chemist separated the pigment that make up the orange color using paper chromatography. The results are shown in the diagram, and so you have the orange dye is placed on a line drawn in pencil. And so it asks us here to add 3 labels to the diagram to show the solvent, where the baseline should be, and that's the line drawn with pencil. And they said where the original position of the spot of the orange dye should be. And so we're going to have a baseline here, and of course, then the original position of the spot will be just on that line or slightly above it. And then the solvent will be below the baseline and also the color. All right. And so for part 2, it's a stated number of different components that make up ink. And basically, you'd have a solvent in ink and you have the pigments. So those are the 2 general things that make up ink. However, you would have some additives, and some of those additives will be like binding agents and so on, or enhancers. All right, but the general idea, you have solvent and pigments. All right. And of course, I know because of 1 mark, they're looking for pigments, which is the most important one. All right, are different colors. All right, because that's the purpose of paper chromatography, to separate the colors or pigments. All right, for part 3, it said explain why the baseline must be drawn in pencil. And it is drawn in pencil simply to prevent separation of colors that might mix with the colors of the ink. And again, because pencil is only made up of carbon, which is graphite, and so there's no color to be separated generally. It is dark, but the dark color will not be separated from it, right? So more likely, if it breaks down, that's fine, but it's not going to separate in the colors. That's the most important thing. For part C here, which is the last part of this question, it said the solvent ethanol was used in this chromatography experiment. Give one other use for ethanol, and it can use as fuels, definitely for consumption, because ethanol is drinking alcohol. All right, that is fine in rum and wine and so on. All right, it can use for cleaning as well, because it can use to remove certain stain or paint. All right, and it can definitely use as a disinfectant. All right. All right, I think I have too much thing right here. All right, let me just correct that real quick. All right, no change. Okay, all right, I'll leave it as it is. All right, but I have 2A and T there. All right, so I get to see the correction. All right, for question number 2, is the atoms are the smallest particles of matter. All right, and for A, it said these forms of matter are composed of 3 particles, which are known as the electron, protons, and neutrons. And for part 1, it said complete the table for these particles. And so we have relative mass for electron is 0. We really don't have a mass. There's a true mass, but the relative mass is 0. Proton 1, neutron 1, and then the charge of an electron is negative, and the charge for proton is positive, and the charge for neutron is 0. And that is why we know that the mass of an element is made up of proton and neutrons, simply because they are the particles or the subatomic particles with mass. All right, so part 2 is a state why an atom is electrically neutral, and simply because they're equal number of protons to equal number of electrons, so therefore there are equal number of positive charges to equal number of negative charges. And so technically they cancel out the effect of each other. All right, for part B, we said write the electronic configuration for chlorine atom, and that will be 287 because it is proton number 7 or 17, I should say, not 7, 17 proton or 17 electrons. All right, for part C, it's the atoms combine by forming bonds to produce new types of particles. And it said explain the difference between ionic bonding and covalent bonding. And in ionic bonding, there is a transfer of electron or electrons from a metal to a non-metal, while for covalent bonding, it is the sharing of electron or electrons between non-metals. All right, so of course, ionic bonding involves a metal and a non-metal, and covalent is only non-metals. And also, other difference here is that in ionic bonding, there's a transfer of the electrons, and for covalent, it is a sharing of the electrons. All right, so those are the two differences included there. Notice it's 2 marks. All right, answer for part 2 is said nitrogen chloride, all right, or you can say nitrogen trichloride, is a simple covalent molecule. It said draw the dot and cross diagram for one molecule of nitrogen chloride. All right, only show the outer shell electrons, and so we'll have it just like this. Remember that nitrogen has 5 valence electrons, while chlorine will have 7, and they will all form single bond. How we know single bond? Because all group 7 elements only form single bonds, or basic single bonds. All right, so they are monovalent bonds. All right, and so it will look just like this. Single bonds between each atom, and then the remaining from the 5 electrons from nitrogen on the outside. And for chlorine, you put 1 in, and those that are in dots, those are for chlorine, remainder 6 on the outside. All right, so we have 3 single bonds there in the structure. For part 3, it says state one difference in properties between ionic and covalent compounds. And I give you a number of differences right here. For ionic compounds, we have high melting point, we have low melting point for covalent. We have high boiling point, we have low boiling point for covalent. Ionic compounds usually conduct well, not even usually, can conduct electricity when molten or in aqueous solution. However, for covalent compounds, they are insulator or do not conduct electricity in the molten state or in aqueous solution. For ionic compounds, they normally exist as solids, while for covalent compounds, they normally exist as solid, liquid, or gas. So you can have all different states for covalent compounds, while for ionic compounds, usually solid, in solid states. All right, so next question in number 3 is the diagrams show the preparation of an insoluble salt by precipitation. It's the reactants are barium hydroxide and sulfuric acid. And so we have stage 1 right here. It said mix the solutions of the reactants. And so we're going to put the barium hydroxide and sulfuric acid in the container to mix them. And in the second stage here, if as you notice, we have filtration taking place. What you're going to get here is the barium sulfate as the residue. And of course, water will pass through as the liquid. All right, because the 2 things we get here is barium sulfate and water. All right, and we separate those by filtration. And the reason we could do that because barium sulfate is insoluble, and then you could wash the insoluble salt, which is barium sulfate, and then you could dry it in the last stage. All right, so they asked us here to name the substances that form the precipitate and the solution. And so the precipitate right here is barium sulfate. And just to make a mention here that they kind of make a mistake in terms of, say, a solution. And I'm going to give you the options here. And so technically for this, because since we use sulfuric acid, what we get, and we use barium hydroxide. So notice barium hydroxide. What we end up with is really water. We get here is barium sulfate with water, and so water is a liquid, not a solution. So that is a basic mistake. But however, though, if the barium hydroxide reacts with sodium sulfate, right, what you'll get is really a solution between you get an insoluble salt with this barium sulfate, definitely, all right, and sodium hydroxide. All right, so it will be a different case if you have to use sodium sulfate instead of sulfuric acid. All right, so that's a big difference right here. So this would be a difference in terms of getting a solution. So if they replace the barium, the sulfuric acid with sodium sulfate, and you still remain barium hydroxide, what you get is sodium hydroxide as a solution. That will be here. Instead, say, please look out for those basic reactions, right? All right, but typically what you get there with the hydroxide and sulfuric acid is water. All right, because just let me go back 1 second. Just remember that when an hydroxide reacts with an acid, what you get is a salt and water. All right, and that's how we know that we only get water instead of a solution. All right, just to make mention of that. So please, let me just go back right here. Please take a note of this bit of information right here. Very important bit of information. All right, still in the same number, but part B. Describe what is occurring in steps 2 to 4. And the first step right there, the second step technically that is on the diagram, but the first step for you right here is really the filtration of the precipitate from the product or products. And remember, the first step is really to mix them or to react them. The third thing you're going to do right here is to wash the precipitate after filtration. And you're going to wash the precipitate or the insoluble salt with pure or distilled water. All right. Again, that extra D's right there. All right. Sometimes those type of will happen. All right. All right. So I'm not able to change them while I'm doing this. I realize the function changes. All right. But anyway, let us highlight those when we see them. All right. So yeah. So washing, and the reason why you could wash the precipitate with pure water or distilled water is simply because the insoluble salt will not dissolve in the water. Okay. That's the only reason why you're able to wash it. And for step 4 is that drying of the salt to remove water molecules to obtain pure salt, all right, or the pure form of the insoluble salt. For part C, it said silver chloride is another insoluble salt formed when 2 soluble salts react. The red equation shows the reactants and products of this reaction. We have soluble salt 1 plus soluble salt 2, and then we get silver chloride, which is product 1, and we get product 2 after. All right, so notice what we have here. Again, only 2 soluble salts. The important thing, we get silver chloride. That's very important. And it said, name the soluble salts and the other product formed in this reaction. All right, and so what we know here is that soluble salt 1, it doesn't matter which one you put before the other, but in terms of preparing silver chloride, you need something with silver. So we could use silver nitrate as a solution. All right, and then again, and a matter of fact, nitrates are normally soluble. That's the important thing right there. Hydroxides are normally soluble as well. And then another salt that we can use here is sodium chloride. All right. And again, you must use something with silver and you must use something with chloride in it because the product must be silver chloride. And that's how we know we can get this thing. Also, is important, you must use something or a metal or a solution that contains a metal that can replace silver as well. And sodium will be more reactive than silver, so hence it can replace silver in silver nitrate. So those are very important things to look out for. And so if you use silver nitrate and sodium chloride, what you will get is definitely silver chloride and sodium nitrate. All right, and so hence we know our other product. All right, they say a soluble salt can be formed by adding a soluble base to an acid. This results in neutralization. And here it asks us to explain neutralization in terms of ions. And very important is that when a base and an acid react, then what will happen here is that bonds are broken to form free radicals, and those free radicals are normally form of ions. And say from the acid, I should have a comma right here, hydrogen ions are displaced and form the base. All right, and from the base, what we're going to have is hydroxide ions. All right. And so again, important, from the acid, we have hydrogen ions, and from the base, we have hydroxide ion. All right. And then what will happen here is that the hydrogen ions will react with the hydroxide ions and form water. And hence it will be neutral, because water is a neutral substance. And hence we call it neutralization. All right. So acid react with base is a neutralization reaction. Now, next question, question number 4. Is a construct a fully labeled diagram of the electrolysis cell to decompose molten sodium chloride. Again, this is molten, not a solution. So what you're going to simply have here is you must have a DC supply. Why? Because in the positive and negative side, all right, and hence once you have a positive and negative side, what you're going to have is a cathode and anode. So these are the electrode right here. So we have the negative side is the cathode and the positive side is the anode. All right, and then we have the molten sodium chloride that will be here. Molten meaning going to be in a melted form. And from the sodium chloride molten form, what you're going to get is some sodium ions and some chlorine ion. Sodium is a cation ion because it's positive, and cation ions move towards cathode. All right, and an anion, which is the chlorine in this case, or the chloride ion, will move towards the anode. All right, so negative move towards positive, positive move towards negative. And here I said name the products of the electrolysis of molten sodium chloride. And again, we get some sodium ions and chloride ions. All right, and they said name it, but I also put the symbols. So Na plus and Cl minus respectively. For part C, is aluminum is extracted from its ore by electrolysis. Name the ore from which aluminum is extracted, and that is bauxite. And this is the form of a bauxite right here, which is Al2O3 with 2 water of crystallization. All right, for part 2 is to explain why extracting aluminum from aluminum ore is more expensive than extracting iron from its ore. All right, and very well, the basic thing that makes this process expensive, it requires a lot of electricity or energy. All right, that's one of the basic thing right here. And so let us read this quickly. It said it requires a lot of electricity to extract aluminum. And it said the aluminum oxide formed from bauxite has a high melting point. That's also very important, and requires a lot of energy to melt it, all right, or to make it become molten, because that's the idea. You must melt the aluminum oxide that is formed from bauxite. All right, so you use a lot of electricity for electrolysis process, and also to make the aluminum oxide that is formed in a molten form, it requires a lot of heat energy. All right, so heat is required right here. All right, for part 3 is a state why it is important to recycle aluminum. And very important right here is that, as coming from the first part of this question here, or part 2 of this question, it's really to reduce the cost of extraction from its ore. It's expensive, so why go through the entire process again when you can just recycle what is already formed? All right, and again, also another one here, which is environmentally applied, is that it's a reduction of the depletion of its natural resource. All right, so that's also important. Instead of using bauxite and depleting the earth, then yeah, we have it already. Is to give one reason why aluminum is used in the manufacture of airplanes, and it is lightweight one. It is corrosion resistance properties is also another one. Its strength, and also its resistance to UV damage, because remember it will be flying at a certain altitude and exposure to UV light, and so definitely it can resist damage from UV rays. All right, for number 5, is a calcium and magnesium are found in group 2 of the periodic table. Is to name this group, and that is group 2 is alkaline earth metals, and group 1 is alkali metals. All right, so those are 2 different things. Notice the difference between group 1, alkaline metals, and alkaline earth metals. All right, and so for part 2 is to give one property of elements in this group. And yes, they're very reactive. They're not pure in nature. They do not exist as a pure element in nature like that. They have 2 valence electrons for sure. They generally form basic compounds. They have low electronegativity, conducts electricity as well. And for part 3, said magnesium oxide is an ionic compound, which is MgO. It said draw a dot and cross diagram to show bonding in magnesium oxide, which is MgO. Only show the outer electrons. And of course, magnesium is from group 2, so you have 2 valence electrons. Oxygen is from group 6, you have 6 valence electrons. Those are in dots, and you transfer those two over. Remember, it's an ionic bond, so electrons will be transferred rather than sharing. And so the table shows melting points and boiling points of some metals and non-metals. It's a use the table to answer question B and C. And so let's take a quick look on the numbers right here. So please make a note of the numbers. And it said identify the following substances. And the first one, it said a non-metal that is liquid at room temperature. And so looking for non-metals such as bromine, chlorine, all right, and sulfur. As out of those three, it's a non-metal that is liquid at minus 200. So what is key you're looking for here is the melting point, which means when it reaches 200, it starts to melt, which is moving from solid into liquid. So if you look at fluorine, it starts melting at minus 220. So by the time it reaches negative 200, it is already a liquid. That's when it starts to melt. All right, there. All right, so this will bromine we go all the way up to negative 7, which is way far from 200. Also sulfur will have to go to 115. That's way up in the positive side. All right, it's an element that is a solid at 440 degrees, and 440 degrees, that is aluminum. Looking for metals right here. Notice it is a liquid at 660. So it is still a solid at 440, all right, because you don't even reach close to that yet. Just doing the 600, all right. An element that is green-yellow gas at 0 degrees Celsius, and even by the nature of the green-yellow, not is chlorine, but let's go with gas at 0. So if you look at chlorine carefully, all right, it is boiling at negative 34, so it is already a gas before it reaches 0, all right. So definitely chlorine is our answer. Two things: the degrees, which is the temperature, and the color. Part 4 is an element that has a full outer shell of electrons, and that is neon. It is a noble gas, so we know that right off the bat. And here it said an element that is a metal at liquid at 20 degrees, and let's go right here. You're going to see mercury. All right, and mercury start to melt at negative 39. So by the time it reaches negative 20, as they suggest, it will definitely be a liquid at 20 degrees, and not even negative 20. At 20 degrees is already a liquid, way liquid before that. All right, and next part of question right here, question number 6, is that the flow chart shows steps in the industrial manufacture of sulfuric acid. And so here is the production of sulfur dioxide, the first step that happened here, just to give you in short. And then what you're going to happen, you're going to put that gas added to the molten sulfur. You're going to add oxygen or dry air. And they want to get the sulfur dioxide. And then for step 2, you're going to have a catalytic reaction of sulfur dioxide to sulfur trioxide. And that's where you get sulfur trioxide right here. And so gas B will be the sulfur dioxide coming from the first part or the first step. Add oxygen to that. Or you can add some more air, which is, you just say add air or oxygen. Doesn't matter. So gas A is oxygen. All right, and for step 3, what's going to happen here is we form sulfur trioxide. So the sulfur trioxide will react with sulfuric acid at 90%, so it's concentrated. And so what you're going to get here is a conversion of sulfur trioxide into what we call oleum. All right, and then for step 4, we're going to dilute the oleum to sulfuric acid. All right, and so just to mention that right there. And so substance C, which is oleum, will react with water. So it's a dilution process. All right, and so here they said name the method used to manufacture sulfuric acid, and so it is called a contact process. And then for part 2 is identify the substance A, B, and C made during the manufacture. And so what you're going to get here, as we go through, A is our oxygen, or what we call dry air. All right, and then we have sulfur dioxide that is formed. That is the first gas. And then the third thing that will form right here is oleum, and I also give you the formula. So we have O2 for air, for oxygen that it goes in, and then sulfur dioxide is SO2, and then oleum is H2S2O7. And here said name the catalyst used in step 2 of the manufacture. And so we have what here is vanadium pentoxide, which is V2O5, and then it says state the temperature that is used for the reaction in step 2, and that is ranging from about 400 degrees Celsius to 450 degrees Celsius. So that's a lot of heat, and that's why it's production of aluminum. Sulfuric acid is also expensive because a lot of heat is required as well. So notice most of these things require a lot of heat energy. All right. So that's if they should ask you, yeah, sulfuric acid production requires a lot of heat. All right. So it's about 4 times of boiling water. All right. So here now we said B, part B, state the color change of the sugar that is observed when concentrated sulfuric acid is added to sugar. And sugar could be white or brown, so doesn't mention that, but the resulting color will be black. All right, so you can move from brown into black, or white, then brown, then black. All right, because even white sugar will turn brown first, then into black. All right, and then for part 2, it says state the chemical property of concentrated sulfuric acid shown when it reacts with sugar and it becomes it corrode the sugar, so it's corrosive. All right, and part C is the sulfuric acid is used to make fertilizer. Give the name of a fertilizer produced using sulfuric acid, and generally one of the most common one is ammonium phosphate, and also we can have generally phosphate fertilizers. That's another way you could state it, but generally ammonium phosphate is produced. All right, and then you see a business person wishes to build a sulfuric acid manufacturing plant on an island. Is a state one environmental factor that the business person must keep in mind when they decide on the best place for the factory. And one they must think about is ocean acidification. So if it's close to the ocean and you have discharge of waste or acidic waste, then the ocean become acidic. Also, if it is rocky, then you may have weathering of rocks because, of course, acids will rock the rocks and break down the rocks over time. Also, depletion of soil nutrients if it's near farm and so on. And generally, if it's where buildings and plants or agricultural places are, then you can think about the acidic rain. So you have discharge in the atmosphere and the rain could become acidic. All right. And so acid rain, definitely. All right. And so those are some. Of course, you can list some more. Question number 7, we have structure L and M are made of the same element. And it says state the name of the element that is present in L and M, and that is carbon. All right, because here we have diamond for L and graphite for M. And it said name the structure L and M, diamond and graphite respectively. It's a complete table about the properties and uses of structure L and M. And so in pencil, we use M, which is graphite, and the property for that is soft and slippery, so that's why it could mark and leave trace easily. And for shiny, it is going to be L, which is diamond, and is used to make jewelry. And electrodes, definitely graphite electrodes, and it is electrical. They are electrical conductor, or graphite is an electrical conductor. For next part of question, part D, so the diagram shows a molecule of hydrogen, and so we have hydrogen molecule right here. So explain why structure L has a higher melting point than hydrogen, and just to make mention here that compound L, which is diamond, and compound M is, well, not compound M, but the other compound that we're comparing this with is hydrogen molecule right there. And so compound L is a tetrahedron bond or structure, while the hydrogen molecule right here is simply a covalent structure, very simple covalent structure. And then we have many strong covalent bonds within diamond. However, we only have a single covalent bond in the hydrogen molecule. And again, diamond is a more complex structure, and hydrogen is simply a diatomic molecule. All right. Generally, well, this is also another one here that diamond is solid, and while hydrogen is gaseous, and solid require a higher amount of temperature to melt compared to a gas. All right. It's really gaseous anyhow. All right. And last part of this question is to give 2 uses of hydrogen, and one, it is a rocket fuel. It can use to produce fertilizer. Also, it can use in the production of ammonia, and a very important one here, it can use to hydrogenate unsaturated fatty acids to saturated fatty acids. They can use to convert unsaturated fats into saturated fats, and so that's why you could use it to add to oils, for example, to make things like margarine or butter and so on. All right, up to our last question now, and it said describe a positive test for the presence of water. And one test there is using anhydrous copper 2 sulfate, which is white, and you're going to change it from white into blue. Or you can use the blue cobalt chloride paper, which turns pink when water is added. All right, and then for part B, it said when water is industrially treated, two stages of the process are filtration and chlorination. Is to state the purpose of each state. For filtration, you want to remove the solid sediments or impurities, solid impurities, and then for chlorination, you want to destroy the microbes or pathogens. All right. And for part 2, we say rainwater is a type of water that can be collected for personal use. It's a state one way, other than chlorination or filtration. Rainwater can be treated for drinking, and that is simply boiled water. For part C, it says scale deposits can form within pipes due to water hardness. And then for part 1, it says state the name of one metal ion that causes water hardness. And so 3 basic ones we have right here is calcium ion, magnesium ion, and iron itself. All right. And for part 2, it said describe a test that distinguishes between hard and soft water. And so a reagent you could use right here is liquid soap. All right. And what you're going to get here is that hard water will become milky or cloudy, while soft water will form fluffy bubbles or lather easily. All right, so that's the basic method you can use right there. All right. The last part is name one method to remove temporary water hardness, and there's simple heating or boiling. All right, or another way, which is a chemical way, you can add calcium hydroxide, which is lime water, and it will reduce temporary hardness. All right, and so that's the end of the review right here. Thank you for watching, and thank you for being here. And definitely I will see you soon. So good luck on the examination. Take care.